I'm going to introduce Igor Josic, who is going to be the web speaker for today. And to do that honor is me, who's called as Dr. Krishnan Umachandran from India. I know Dr. Krishnan, Dr. Igor, as he was about to complete his, PhD. We were together writing a lot of articles on Industry 4.0, and through which we became friends. He is from the Split University in Croatia.
Uma, I think yours is very quick.
It's echoing. Eh?
Uma, actually, it's very noisy. Okay.
No, I don't. How are you hear me now? Is it the same? You want me to start again? I don't have any issues, but just tell me when I have to start.
I think it's fine. Okay, maybe.
Oh, I have to go again, right? Okay. Again, good morning, Bosnia. Good afternoon, India, and good evening, Singapore and Hong Kong. Friends, I'm Dr. Krishnan Umachandran from India, who is going to introduce the speaker for today. Igor Josic is from Croatia. It is in Bosnia and Herzegovina. He is in the Spirit University there doing his research. He's a research fellow there. He has a very good wide, specialization in the field of technology. He is into digital marketing, that is his core competence. And then through which he entered into e-commerce and finally landed up into creating a Vision 2020 for ICT systems, through which he is now a real specialist on IoTs, giving us a lot of data on the OTT applications that go into the Industry 4.0 platform and for the ICT enablement for the future. So this person, Igor Josic, he is a specialist in this area. He works in a university and he fulfills all the USAT CPM formula for a web webinar. He is in a university. He has a good specialization on the topic. He has authored around 26 articles which are published nationally and internationally. And then he gives himself for a presentation in a lot of conferences which are international. He is a member of many scientific associations and academies, and he is promoting a lot of network among big professionals. As he is such a great personality, we welcome Igor Josic to deliver this address on IoT applications in rural and agriculture sectors. Thank you. I now leave the floor to Purushothaman, who's in Singapore, to tell us who's the host for this day, to tell us what he expects out of this and how he has garnered the needs for this seminar or webinar for today. Thank you.
Okay, hi, hello, and good afternoon, everyone. This is Purushothaman. Actually, I'm based in Singapore. I'm from India, but actually I've been living in Singapore for some time. Okay, so I'm an engineer by heart, by profession, by heart, but I'm a farmer. So I think the idea came up of about this one is because like by heart I'm thinking about how we can employ the technology for to improve the basic needs. Okay. So I feel very great in joining this community, and like we hope we can bring more engineering to the community as well. Okay. I see engineers have an excellent opportunity. Okay, if you see, we are the one who change the way we live, we work, we interact with each other. I think that the contribution of engineers to the world is immense. As we are seeing, we never thought of, where we will be, you look at it 30 years ago, 50 years ago, I don't think we ever imagined actually we'll be here today, but we are here. It's because of the engineering. Okay. As an engineering community, I think it is important for everyone to think about what lies ahead of us, and what are the opportunities, how to recognize, and like, okay, what we can contribute. I think this is one of the initiatives where actually we can like bring in like what is the technology in like, okay, in store for us, and how we can exploit for the purpose of improving the lives, and also like, okay, the make the life easier for everyone. And I'm grateful, I'm thankful to Dr. Umar Chandran, like in bringing this community together. And also I want to thank Dr. Igor, okay, uh, for agreeing to accept, for accepting to address this and talk about this, and being an experienced um, technology guy. I hope actually his lecture is useful for everyone, and I really think the engineering community will benefit from this. And I really like to thank everyone here for making it here, and we hope actually we will continue with this. Thank you.
So thank you for your introduction. Thank you both for your introduction. Good morning, good afternoon, good evening to everyone. I do hope you will find this presentation it will be interesting for you. So let's start. Today topics of this webinar is IoT applications in rural and agriculture sectors. So Krishnan told me about everything important about me. I will just show you my email address and my mobile phone. So if you can contact me, if you want to contact me later by Viber or WhatsApp or email, here are my contact details. And I will present content of today's webinar. So at the beginning, I will explain some grounds for Internet of Things. Then I'll speak about the main definitions and facts about Internet of Things. Then we'll speak about IoT systems, and after that about IoT architecture. So it will be a little bit longer introduction, but after that we'll speak about IoT in agriculture, main facts, then applications and solutions in agriculture, about value chain in smart agriculture, and before conclusion, I will give you all some inputs for following years and decades, and of course we have conclusion at the end of this webinar. At the beginning of this webinar, I will explain you two very important terms that is important not only for IoT applications in agriculture, but also for IoT in applications in any business segment. So the first one is smartphone society. That term is introduced by consulting firm Roland Berger, and it's really explains society in which we live. So this is a smartphone society because almost all of us, or all of us, have at least one smartphone, or even more than one smartphone. So this is really smartphone society, and this is important to know later when we speak about some IT applications and solutions in IoT for IoT in agriculture. The other term, very important, is shift in mindset. That term was introduced by Ericsson experts. And this term explains differences between new products and services and former products and services. That means we all will have to do a shift in mindset regarding creating new products, new services in industry 4.0 era. One of the main base technologies for IoT is 5G mobile network. The main fact that the user will buy the speed of internet access and use different applications. At this moment today and in the past years, customers or users bought tariff models with subscription fee and minutes, data, and SMSs inside it. Now we are going to new period, Industry 4.0 era, that customers will buy speed of internet access 20, 50, or I don't know, even 100 megabit per second per user, plus different applications. This explains shift in mindset. So telecom operators on the first place, but after that, and solution providers and applications and service providers, will have to do this shift in mindset and start thinking about new ways of products and services. And it is very important for massive usage of IoTs in agriculture, but IoTs also in smart medicine, smart cities, smart homes, etc. What are the main requests for 5G mobile networks? In the first place, peak transmission rate greater than 10 gigabits per second. If you compare it with today's speed of internet in mobile networks, it's much faster than now. Up to 100 times more connected devices on the network than in the present systems. So this is important for massive usage of Internet of Things in every business segment. So it's the same thing for IoT in agriculture. Mass production and availability, especially for the price issue, sensors and different devices, longer service life of batteries in devices. It's a very important item for IoTs. Then speed access for customers up to 100 megabits per second wherever it's needed. Transferring more than 10,000 times of data traffic than in today's systems. And it's also important for IoTs and massive usage of IoTs. One of the most important items is delay less than 1 milliseconds, especially interesting for industrial Internet of Things and autonomous vehicles and traffic congestions control. Then higher ultra reliability of the system and almost 100% coverage of the population and territory. These 9 items define requests or requirements for 5G mobile network. What I explained now, it's shown on this picture. So we will have unlimited experience with 10 gigabits per second peak data rate, with 100 megabits per second whenever it needed, and 10,000 more traffic. We will have instant access with ultra reliability and with radio latency less than 1 millisecond. And of course, 5G mobile network will be for everything and for everyone with items 100 more devices than now, M2M with low cost and 10 years long batteries in devices. I always like to explain new systems and new technologies with some well-known systems or architectures. So here I have chosen a comparison with railway composition. If we want to have a railway composition, we have to have a railway embankment, then rails, of course, locomotive, and many wagons. Of course, we have to have also a driver. So if we compare it with new technologies, with Industry 4.0 era and the new technologies that will be important for business segments in following years and decades, railway embankment will be fiber optic infrastructure. Without fiber optic infrastructure, we will not have anything. We will not have 5G mobile networks. We will have not IoT's massive usage. So fiber optic infrastructure everywhere in up to fiber to the home or fiber to the offices will be crucial and very important. If we compare rails, it will be SDN, software-defined network, and network function virtualization technologies. Locomotive, of course, will be 5G mobile network, and 5G mobile network will have to pull all wagons. Wagons will be different IoTs. IoT in smart cities, IoTs in smart homes, IoTs in industrial Internet of Things or in agriculture. Of course, different OTT services, over-the-top services, cloud services, etc. Of course, we have to have driver of that railway composition. So remember, IoT in agriculture will be only 1 or maybe 2 wagons in the whole composition. But before that, we need to have very quality fiber optic infrastructure, very quality transmission systems, and high quality locomotive, so 5G mobile network. These are very important preconditions if we want to have many wagons based on IoTs, OTT services, and cloud services. This picture explains one important thing. 5G is not another generation of mobile network. 5G is much more, and difference between 5G and 4G will be much more expressed then between 4G and 3G or 3G and 2G. 5G, I repeat, it's not only a new generation of mobile network, it will allow the customers and the users many new things and many new experiences. And it will be much faster, much greater, and let's say better than 4G mobile network. So let's speak about Internet of Things, one of or several baboons in this railway composition. What are really the Internet of Things? There are many different explanations and definitions, but I have chosen here only one. The Internet of Things is a network of physical objects accessed through the Internet. These objects contain embedded technology to interact with internal states or the external environment. This explains really what Internet of Things mean. There are many other definitions from different sources, Wikipedia or some IoT organizations and development institutes, but I have chosen one to show just explain what the Internet of Things really mean. The industrial Internet of Things is quite a bit different, although they have the same base. But industrial Internet of Things is a network of physical objects, systems, platforms, and applications that contain embedded technology to communicate and share intelligence with each other, the external environment, and with people. Of course, it's more complex than the first one, but if you compare it, it's similar. Of course, this is enlarged with physical object systems and platforms, because industrial applications will be more complex than applications or solutions in smart homes or smart cities or smart agriculture. There is another term. I believe you will find it in literature, or you have already found it. The Internet of Everything. This term has been introduced by Cisco experts and explains much more than Internet of Everything. So Internet of Things. Internet of Everything brings together people, processes, data, and things. So let's say that Internet of Everything builds on the foundation of the Internet of Things by adding network intelligence that allows convergence, orchestration, and visibility across previously disparate systems. Internet of Everything means similar like Internet of Things, but it's built on foundation, and it includes people, processes, and data. So what are the three key components of IoT? Three main components in IoT is computer infrastructure, communications infrastructure, and devices or things. It's shown on this picture how it looks like. And important to know that each Internet of Things in the market, in the network, has to have their own IP address. It's very important that we implement IPv6 addressing because of massive usage Internet of Things or everything. Without IPv6, we will not have massive usage of IoT or Internet of Things. Why is that so? If we compare a number of different addresses in IPv6 and IPv4, we can see a huge difference between IPv6. So we need IPv6 addressing in whole internet network on all levels because of massive usage of Internet of Things. I mentioned each Internet of Things has to have their own IP address. When we speak about applications and solutions of everything of things, we can say that Internet of Things will enter in our segments of our lives or of our businesses. When we see a picture from 2015, we see that people presented that IoTs will be part of our lives. We will have it in smart homes, smart cities, regarding environment, energy savings, retail, logistics, of course, agriculture, industry, and medicine or smart health, smart medicine. If you see this circle, agriculture, there are only two applications or solutions that are noted here: smart irrigation and greenhouse. we'll see later that there are more than 40 or 50 different applications or solutions that have been developing last years. So from 2 smart irrigations and greenhouse, we are now speaking about 30, 40, or 50 different applications and solutions, and there are applications in smart farms. More than ever before, it's needed to be creative. We have to be creative if we want to have to create new services, new products, and that creation of new products and services meaning a shift in mindset. Offers of products and services must not be based on the customer's needs, but mobile telecom operators on the first place, and their partners might say to customers what they need. It's important to remember, because there are many areas of the economy in which we can make progress. If we see what Steve Jobs said, it's very simple to understand what it is meaning. Some people say, give the customers what they want, but that's not my approach. Our job is to figure out what they are going to want before they do. I think Henry Ford once said, if I'd asked customers what they wanted, they would have told me, I want a faster horse. People don't know what they want until show it to them. That's why I never rely on market research. Our task is to read things that are not yet on the page. So remember this, offers of products and services must not be based on the customer's needs, but we, especially from ICT sector, and especially mobile telecom experts and operators, must say to customers what they need and what they want. What are the 4 key challenges for IoT systems? 4 key challenges to be addressed before mass deployment are as following: platform for IoT, platform for IoTs, connecting of devices, business model, and of course killer applications. Applications those will lead the massive usage of Internet of Things. Other challenges can be summarized in 5 different items. So different IoT devices using different protocols, and it's still a problem, but I believe it will be solved during following years. A lack of maturity in IoT technologies and processes. Physical security devices. There is still limited way and access management and control of IoT devices. And the 5th one, but in my opinion, one of the most important ones, limited knowledge of software experts. We need more software experts in IoT segment, and I think there are many job openings in this segment, and we still need real quality software experts for this business segment. The main problem of massive implementation of IoTs is the safety and protection of access by unwanted people. Regarding several market research from 2015 to 2020, more than 60% of respondents cited this as a major obstacle to the mass introduction of IoT. So the main problem is protection of access by unwanted people. In second place is integration of the devices into the system, and of course, on the third place, investment in network infrastructure. We need a lot of money for implementation first IoT systems in IoT architectures in a network. According to GSM Association, there are 5 factors involved in the chain of defining and ensuring the security of access devices. On the first place, we have providers of IoT platform services. Then we have manufacturers of IoT devices, so meaning IoT device vendor. Network mobile telecom, mostly mobile telecom operators. Then companies or individuals responsible for development of IoT applications, and in the middle of this value chain, IoT service providers. This is shown on this picture. So in the middle of this value chain is IoT service providers, and together with IoT service providers, working together, IoT service platform providers, network operators, IoT device vendors, and IoT application developers. The IoT system architecture consists of devices, restricted communication systems ZigBee, NFC, Bluetooth, etc. Wide range transmission system, WiMAX, 4G, 5G, satellite communications, etc. Main transmission systems, middleware platform, and applications for various applications in everyday life. There are three main layers in the architecture: physical layer, transport layer, and applications layer. And all of this, all of this is shown on this picture. So we have five architecture items divided into three layers: physical layer, transportation layer, and application layer. When we speak about industrial Internet of Things architecture, I'll be very briefly pass through this. We can speak about cloud businesses, big data, asset management, monitoring, etc. And in IoT, it's shown on this picture. So cloud services at this moment may be the most important services, but not only. We can speak about many other services that can be implemented in different industrial applications, not only in factories, but in all other business segments. When we speak about industrial Internet of Things architecture, there are four main layers in this IoT architecture. So one more layer than if we compare it with industrial Internet of Things. We have a physical layer, or the things layer. We have transport layer, data transfer layer, middleware layer, and application layer. So if we can see on the picture, it's clear that there is another new layer. It's a middleware layer because industrial Internet of Things architecture is more complex than Internet of Things architecture for implementations in smart cities, smart homes, etc. Now we'll see the main areas for implementation of IoT systems and devices. We saw the picture from 2015. There are almost all segments of our lives and business segments that will use a massive deployment of IoTs. But what are the most used IoT applications and solutions in these days? At the first place, it's smart cities, city management. Then we have automation of family households, homes. That means smart homes. Then industrial Internet of Things, health, smart medicine, and smart agriculture. Smart agriculture at this moment is one of the five most important items for business applications of IoT. IoT in smart agriculture started to be very interesting, especially some parts of the world. So remember, agriculture is on between among first five business areas in IoT business segments. The total addressable market for smart agriculture is expected to grow from USD 13.7 billion in 2015 to 26.8 billion by 2020. It's almost doubled number. So during last 5 years, this business area was going up from 14 to almost $27 billion. And it's huge growth during last 5 years. We can expect bigger growth in following 5 years or in following decade. Now we'll speak about IoT in agriculture. We'll speak about applications and solutions for Internet of Things in agriculture. This before this was just introduction of main technologies that will be used as base for IoTs, and the main facts and definitions about and some facts about IoTs. What are the main drivers for applications, IoT applications and solutions in agriculture? The main drivers will be, at the first place, climate changes, then need for water conservation, and on the third place, emphasis of enhancing efficiency. When we speak about climate changes, it will be needed to stimulate the deployment of IoT-based solutions in agriculture to increase yield and improve efficiency. Climate change will significantly impact agricultural production, especially in some parts of the world. I will not explain you in more detail, but it will be very visible in Mato Grosso in Brazil, Midwestern United States of America, Eastern Australia, due to extreme heat. Then we need IoT applications and solutions in agriculture because of water conservation. Agriculture consumes nearly 70% of fresh water. Applications such as smart irrigation, one of the first applications and solutions in smart agriculture business segment. These applications will help to save water in agricultural applications. Leveraging of IoT for water conservation will be major trends in the future of agriculture. So if there are any solution providers, and there are application providers, software developers among you who listen to this, remember that leveraging IoT for water conservation will be a major trend in the future of agriculture. Emphasis on enhancing efficiency. Smart agriculture enables farmers to optimize costs and efforts associated with agricultural activities, to optimize various agricultural resources such as seeds, fertilizers, and pesticides, along with human labor, to reduce energy consumption and fuel usage, meaning minimize costs, and to enhance productivity by guiding farmers to expertly invest both time and resources in the appropriate combination to achieve the perfect balance for optimized production. What are the main restrictions for implementation of IoTs in agriculture? On the first place, fragmented agricultural market, then lack of connecting services for the agricultural market. On the third place, high capital investment requirements, or maybe this is the first position, and data management for agricultural decision making. When you speak about fragmented agricultural market, the agricultural market consists of many small markets and segments, and they all have different requirements and properties. Problem is how to minimize costs, because all markets have their special features, special properties. Fragmented agricultural markets also make a problem for maximizing return on investment, which is one of the most important items when we speak about financial parts of implementation of IoT in this business segment. On the third place, a lack of connecting services fifth place, a lack of connecting services for the agricultural market. Connecting services in agriculture have not yet reached the technology's maturity level, such as in smart cities and smart homes. I told you before that smart cities, smart homes, and industrial Internet of Things are top 3 business segments for IoTs, and these services in agriculture have not yet reached that technical maturity. But I believe, and I strongly believe, that it will be happened very soon. Telecom providers, on the first place, with their partners, they have the pursuit to expand services for the agriculture sector by partnering with other players. In my opinion, I'm from telecom sector. I work with telecom operator. Telecom operators have to lead all these business segments in business chain inside of it. It's expected to be a new partnership in the future, which will help the smart agriculture development. I believe, again, telecom operators have to lead all this project together with partners, with solution providers, with application providers, with software developers, etc. High capital investment requirement. It's needed a significant initial investment to establish and revolutionize the existing field infrastructure. And if farmers want to set up and deploy of capable and sustainable IoT ecosystem, the high cost of adopting such smart solutions is a serious challenge for farmers, especially in developing countries. And I think the states or countries or counties or some municipalities, and of course different financial organizations, have to find their opportunities in this part of business segment. Countries, developing countries, and their counties inside them, together with the different banks and financial investment institutions, have to find their opportunity and help to build new farms, so-called smart farms. Data management for agricultural decision-making, one considerable barrier is the efficient use of data, the lack of industrial standards. So if we have data, if we collect data by different devices, how can we use it in practice? How can we use, if we measure some temperature, the speed of wind or some humidity, how we can use it to get some action on a smart farm. So data management for agricultural decision-making is still in progress, and the difficulty is rooted in the requirement to standardize the data management system throughout the agricultural industry to ensure widespread uniformity of operation. What are main opportunities? Of course, expansion of smartphones and internet penetration. I told you that we live in smartphone society, so we have already lived and we be living in smartphone society, and smartphone society will have just more and more penetration together with internet penetration, increasing public-private partnerships and increasing adoption of technologies. Who or which companies have do have great chances? When we speak about expansion of smartphones and internet penetration, that fact is very important for, at the first place, mobile telecom operators, other service providers, application developers, solution providers and developers, device manufacturers. When you speak about increasing public-private partnerships, that is huge change for countries, states, and counties. Of course, different municipalities, different investors, different financial institutions, agriculture development authorities, food and beverages manufacturers, etc. Increasing adoption of technologies is important for, again, telecom operators, service providers, devices manufacturers, international application developers, and local software companies. I'm from telecom sector. I work with telecom operators, or I've been working for the last 24 years, and I'm sure I can see the huge opportunity of implementations of IoTs in different business segments, and one of it is IoTs in agriculture. Here is value chain of the smart agriculture. So on the first place, we have device equipment manufacturers. Then after that, connectivity providers, low power wide access, wireless access, ZigBee, Wi-Fi, operators, etc. Mobile network operators, connectivity platforms, application providers, data analytics, system integration, outsourcing providers, and end users. So these 8 boxes explains the main things, main items of the value chain in IoT in agriculture. Which companies will be able to find their interest in the value chain? I will repeat again, the device manufacturers such as Huawei, Xiaomi, Ericsson, Nokia, Logica, and many others. On the second place, or maybe on the first place together with device manufacturers, will be telecom, especially mobile operators. Then service providers, for example, different local internet service providers. Connectivity, local providers for LP, VA, Wi-Fi, ZigBee, etc. System integrators such as IBM, Logica, Accenture, etc. Similar. Different IT service providers, application developers, freelancers and companies which will deploy and different applications. Owner farms, countries, counties, municipalities, and many others. So almost each company in ICT segment has to find their opportunity or their opportunities in implementation IoT in agriculture, but not only in agriculture, in each business segment where, which I mentioned before. So in almost every part of our lives of our business segments. I am from telecom operators and I am from telecom sector, so I will briefly explain one thing for those people who work in different telecom operators. Telecom's perspective today, providing mainly connectivity. But in near future, mobile operators can provide 3 categories of services for increasing market share. On the first place, full connectivity. Then vertical integrations, end-to-end solutions, or how we often say, turnkey solutions. Partnership with equipment devices manufacturers, IoT solution providers, non-cellular service providers, etc., to offer this type of services, turnkey solutions. Telecom operators in the very near future must support IoT deployment of multiple levels. So provisioning, authentication, security, billing devices, management, location-based services, applications, analytic services, etc. So from today's only connectivity, telecom operators have a huge chance for providing many other products and services, and of course earn much more money together with their partners. And of course, regarding they will help the smart farms to be better and earn more money. I always say that we need a win-win-win situation. So win for ICT segment, win for states and countries or counties, and win for smart farms. These three wins means that we will have successful applications and solutions. When we speak about IoT applications and solutions in agriculture, this is a block diagram which explains what we have in smart farms. So we have devices that we have network topology, which connected measuring data from devices to gateway, and then we have the transmission from gateway to data storage. After data storage, we have to analyze this data, and then after that we will have implementation of this data on the farm. We need very strong data storage, but on the first place we have very high quality measuring of data on site, and analytics for data that we storage. So these boxes, analytics and implementation, will be in the focus in following years or in following even following decades. I mentioned at the beginning that we had only two applications and solutions: smart irrigation, and we had also greenhouse. Now, in this picture, I found it in review of practice and implementation of the Internet of Things for smallholder agriculture. There are 5 circles, 5 segments with many items in it, almost 5-6 in each of these circles. So when we speak about climate, we can measure humidity, radiance, precipitation, pressure, wind. When we speak about livestock, we can measure and monitor disease, location, milk quality, predator, supply chain, plant, of course, disease, color, etc. So when we see this picture, it's clear that many solution providers, application providers, and telecom operators can huge opportunity to help and build new smart farms or smart agricultural farms for the future. Here's picture for explains Europe agriculture market. 4,500 manufacturers, almost 450 machines, $26 billion, and 135,000 people, which work in prestige agriculture farms. So at this moment in Europe, almost 70 to 80% farms and equipment has some form of precision agriculture, so some kind of smart agriculture. So 70 to 80% in Europe of whole number of entire number of farms have already implemented some kinds of IoTs in their everyday business. I have chosen also this picture to show you one very important thing. If you develop some solution, if you develop some application, some form of new products and services, remember one thing: you have to find a way to create user-friendly interface. Smart farms will be better if farmers can use with applications with user-friendly interface, and if they can solve their problems with 1 or 2 or even 3 clicks. If you have if you create excellent solution, excellent application, but if it's complicated for usage, they will not have so huge success, such as some application or some solution with user-friendly interface. UFI is very important. Remember that shift in mindset and with smartphone society, user-friendly interface is also crucial when you crucial thing or item when you create new products or services. This picture explains one important thing. At the beginning, we have product. Then we have a smart product. And at this moment, we have maybe on the most farms, smart connected products. We need to have product systems and system of systems. In following years, in following decades, we all will have our opportunities for these applications and these services. Although I mentioned in Europe, 70 to 80% of farms have already used some type of IoT applications. There are many spaces, there are many requirements for new types of applications, new type of services, and we need to move forward the product system and, of course, the system of systems. This picture very clearly explains that we started working with applications, IoT applications in smart farms, in smart agriculture, but we need to have a lot of steps in the following years to get to be better and better, and to get system of systems in smart farms. 5 years ago, we had only 2 or 3 applications: smart irrigation, greenhouse, and maybe something else. But I know that these 2 applications were very used before. Now I found in this paper there are 4 pilots: dairy, arable crops, meat and vegetables, and fruit pilots. So there are 4 pilot segments with many items which have been developing for smart farms and for applications and solutions in smart farms. Remember this, although we have already started working with solutions, there are many spaces, a lot of spaces for all of us to implement our solutions, our applications, and of course help to build new farms and farms for the future. Before conclusion, I will give you some inputs. Some inputs regarding where we can work together, where we can start implementing applications and services and solutions for farmers. On the first place, precision farming. Precision farming is an approach to farm management that uses IoT and information and communications technologies to optimize returns and ensure the preservation of resources. Precision farming entails the obtaining of real-time data of the conditions of crops, soil, and the air. So everything, almost everything in the farms. This approach aims of ensuring profitability and sustainability while protecting the environment. Think about it, and you will see that there are many opportunities for new applications and services. Just we all need creativity. A variable rate technology. VRT refers to any technology which enables producers to vary the rate of crop inputs. It combines a variable rate control system with application equipment to apply input at a precise time or location to achieve site-specific applications rates of inputs. So this technology will enable producers to vary the rate of crop inputs, and so for all farmers, it's very important that they control and manage this. Smart irrigation, one of the oldest applications. The need to enhance the efficiency of irrigation processes and minimize water losses on the rice. So water conservation will be one of the most important items in the following years. And of course, minimizing water losses is part of it. There is an increasing awareness of conservation of existing water resources by employing sustainable and efficient irrigation systems. IoT-based smart irrigation measures various parameters such as humidity, soil moisture, temperature, and light intensity to calculate the precise requirement for water. So we need measuring, we need data storage, and we need data analytics, and then implementation of this data. Implementation meaning a reaction for measuring data. It has been proved that such mechanism can contribute to higher irrigation efficiency. Irrigation efficiency will be very important for water conservation. Agriculture drones, we can use drones in almost each segment of our business. So one of these will be agriculture, and it can be used in multiple agricultural applications such as monitoring of crop health, agriculture photography for site-specific development, variable rate applications, and livestock management. Drones can scan a vast area of low coast and work with different sensors to get a wide range of information at ease. Smart greenhouse, also one of the oldest solutions and applications in smart agriculture. The smart greenhouse allows farmers to cultivate crops with minimal human intervention. It is very important. Climatic conditions such as temperature, humidity, luminosity, and soil moisture are continuously monitored inside the greenhouse. Variations in these conditions will trigger automated actions. So again, monitor, data storage, action, analytics, and then action. These actions will then evaluate the changes and implement corrective actions to maintain optimal conditions for plant growth. Yield monitoring is the mechanism to monitor various aspects of corresponding to agricultural yield, such as grain mass flow, moisture content, and total quantity of harvested grain. Yield monitoring offers real-time information for farmers to facilitate decision-making. Yield monitoring helps to reduce operational costs, of course important for smart farms, and enhance productivity. A farm management system assists farmers and other stakeholders with information collection and management by leveraging diverse sensors and tracking devices. The retrieved information is then stored and analyzed for conducting complex decision-making tasks. Stored and analyzed for conducting complex decision-making tasks. I repeat again, we need monitoring, we need storage, analyzing, and then implementation on a reaction. FMS also enables the identification of best agricultural data analysis practice and software delivery models. Other benefits include reliable financial data and production data management and improvement in risk mitigation capabilities regarding weather and unforeseen events. Soil monitoring system, such system can assist farmers in tracking and improving the quality of soil to avoid degradation. They allow for the monitoring of a number of physical, chemical, and biological properties such as texture, water holding capacity, and absorption rate. Soil monitoring can help minimize erosion, densification, salinization, acidification, and pollution by toxic elements that can degrade soil quality. Precision livestock farming, similar such as precision farming. Precision livestock farming supports real-time monitoring of productions, health, and welfare of livestock to ensuring optimal yield. Advanced technologies allow continuous monitoring and can facilitate farmers with decision-making to ensure improved health of animals. At the end, conclusion, smart farms is the future of agriculture business segment. I mentioned many reasons for that: climate changes, water conservation, soil monitoring, yield maximization, and optimization, etc. IoT, Internet of Things, and all relevant technologies, 5G, optic fibers, 5G, and many others, will be a crucial part of such farms. Smart agriculture is one of the top 5 business segments after smart cities, smart homes, industrial Internet of Things, and smart healthcare. But I believe in following years, they will be at least on the 3rd place because many companies started investing in this part of a business segment. Mobile operators, system integrators, application developers, and many other companies from different business segments have great opportunities to grow their businesses in Industry 4.0 era together with smart farms. Creativity from all these companies and partnership with farms and partnership one with each others will enable creating new revenues and business opportunities. And remember, the goal is to achieve win-win-win solution. WIN for ICT segment, for telecom operators, for solution providers, for application providers, software developers. WIN for countries, states, and different municipalities. WIN for smart farms and farmers. At the end, finally, that's all, folks. For me, I'm here to listen to your questions, remarks, or anything. Thank you for listening.
Thank you very much, Igor. It was a wonderful presentation.
Thank you.
And we have some questions also. I think since you have instilled a lot of interest in this agriculture, IoT, and ICT enablement, a lot of our engineering college students may approach you and ask you for some guidance or project co-working or publication of papers and all such stuff. Okay, keeping that aside, okay, your presentation, which I saw, which really instilled a lot of enthusiasm on me, it was the product making into a smart product and then making into a system, product system, and then you go on to systems to system. The cascading, which you showed, was really a wonderful thing, which will lead to a lot of precision manufacturing coming, I mean, not precision agriculture, coming into the manufacturing segment of the agricultural products also into India. Okay, so having this, how do you see the telematics coming up in agriculture?
Telematics. Many companies will need to invest. There are not only money, but there are experts to solve these solutions. On the first place, device manufacturers and telecom operators, together with all other providers, as I told. Not only telematics, but telematics with data storage, analyzing of data, and reaction for these measurement and monitoring data. Not only in India, but India is a huge country, and many companies would like to work in India, because there are many farms, there are many people in it. But for small countries and small farms, there are many opportunities. They implement that applications for measuring, let's say, soil quality or farm stock, especially let's say in Denmark, farm stocks. I believe they have already implemented many of it, but there are still a lot of space for new solutions, new applications. Let's say in Denmark for precision livestock farming.
Okay, very nice narration, Igor. I was really happy to hear a lot of things on your yield, making up more of productivity, taking care of the livestock. A whole of integrated agriculture was projected by you. I'm really happy. Thank you to you. I'll leave the floor to others to ask questions.
Thank you.
Okay.
If no one asks questions, then Purushottam.
Yeah, sure. Okay. So no, I just want to ask a question. So I think, so in the context of India, so I think it really, there's a lot of context to this area. Like when it comes to agriculture is not the same everywhere. Okay, it is different in Australia, it is different in New Zealand, it's different in US, it's different in US, like Europe, and in obviously it is different in India as well. I see that, okay, in India, there are a lot of levels of farming, okay, from a very a farmer with a tiny land to huge farms. Okay, we can see varying capacities. So what do you see as, okay, this kind of applications as a service? Okay, because so for example, like a small farmer may not be able to afford to get something to go on, but do you see any scope for this to be a platform where actually people can plug into this and then, okay, use what they want?
Yes, I believe the smart farmers needs what they want. Smart need what they want, but also maybe at this moment they even don't know what they can get. So telecom operators on the first place and solution providers have to find solutions for them and show them maybe this will be usable for you and this will help you. smart farmers know for smart irrigation, but maybe there is some another better solution. And we from ICT segment have to be creative and offer them something, let's say smart irrigation 2.0. To help them, and when they accept it, and if it is user friendly, it has a user friendly interface, it will be accepted, and it will be again win-win situation. It's very less time. There is only 1 hour, but I tried to open many opportunities for all of us, and that we can speak later in following days and weeks about many possibilities that we all have in this segment.
Yep, sure. Okay.
I would like to say that this presentation I can send to you, Ignition, and I will put it on my ResearchGate.net profile, so it will be visible and open for everyone.
Okay, thank you. So Uma, actually, I think we are. So is anybody else have a question in this forum? Would like to ask?
Of course, if you have any questions, you can send me later by email or by WhatsApp.
By email as well. Yeah, sure. Okay. So Uma, actually, what's the plan now?
Sorry?
I'm just asking Dr. Krishnan.
No, you just make the validation.
Okay, yeah, sure. Okay. Yeah, I think, okay, as Dr. Uma Chandran said, okay, it has been, it's a great presentation. Okay. I think, it shows that, the agriculture is no more, it's a standalone thing for any farmer. It's connected. I think it is going to be like people have to work together and, okay, think together. And obviously, I also think, the data will, okay, the farmers are going to have more data on their hand, and, how to utilize the data, and, how to make decisions on this data. And that is where actually the IoTs and also okay, the system engineers, whereas the integrators and software providers coming to. But I think, this is a very good, thing for us to start at this point of time. And, if you see in 5 years, as you said, probably it's going to be, okay, it's everywhere, whether it is small or big. I think this is going to be there, and definitely we are going to everyone is going to run into this. So I think, you have really shown, where it is heading to and who are the stakeholders in this. And definitely it is not, okay, some people privately can take and implement. It is no more. It has to, the governments have to come in, the telecom operators have to come in, and the farmers are only subscribers. I think that is how I see it, and that is what I learned from this. And it's a great education for me, and I hope actually everyone had a similar sense, and we hope actually to build on this further and learn more. Thank you very much. Thank you, Dr. Edgar, and hope everyone got what they wanted today. We appreciate it. Thank you very much.
Thank you.
Thank you all. Thank you all. Thank you. Prashod.
Yep.
Okay.
Okay. Thank you. Thank you, Igor. Thank you, Igor. Have a nice time. Bye. Bye.
Thank
Very
you.
nice.
Bye.
Thank you. So let people go, and then we have something to talk.
Yep.